Yeah, so what observation tells you that this reaction is endothermic? No, but see, you don't observe that heat is a reactant, do you? No, you're looking at the reverse, aren't you? At the reverse reaction. So what observation tells you this reaction is endothermic? What do you have to do to make water boil? You gotta raise the temperature. How do you raise the temperature of water? So this is so obvious you don't even want to say it. Okay, heat it up. So how do you do this? Here's your pot of water on your stove, and you're heating up your pot of water. So you're supplying heat to this water to heat it up. So that's why you know it's just an endothermic reaction. Okay, let's go on. Part C. Determine the sign of work of Q, W, delta T, delta H, and delta S for each reaction. So let's do this. So let's see if we have Q and W and delta G. And delta H and delta S. So let's take a look at the NaCl reaction first. So is Q going to be positive or negative? Greater than 0 or less than 0? So this is going to be plus or greater than 0. How do we know that? Yeah, because we said that delta H should be, we knew it was positive or greater than 0. So how is Q related to delta H? Yeah, so remember that there's that formula, Q is equal to delta H. What's the point? Oh, see, this is that abstract stuff about thermodynamics we talked about last week, that Q is a non-thermodynamic property, which means we can measure it directly. Delta H is a thermodynamic property, which is a property of the substance we cannot directly measure it. So we can quantify delta H by measuring Q, and then by setting them equal to each other, we can make one each other. Yeah, so it's more of a, well, I'll say it's more of a technical thing, but really, we say that delta H and Q are the same. Okay, so what else can we figure out immediately? W, delta G, or delta S? Pardon? Delta. So can we figure out W right away without doing any calculations or? Yes. So is work going to be greater than 0 or less than 0? Or equal to 0? How do we know it's equal to 0?
There's no gases.
Yeah, so there's no gases, so this is going to be equal to 0. Okay, so no gases involved. What can we say about delta G? How do you know it's spontaneous? How do you know it's less than 0? Okay, by oxygen. Yeah, so if you put salt in water, does it dissolve? So since salt does dissolve in water, we know delta G should be, yeah, it should be negative, less than 0. So Jeff calculated delta G to be less than 0, and Jeff, what did you calculate for delta G?
Negative 9.07 kilojoules.
Minus 9.7 kilojoules. And what about delta S? Greater than 0 or less than 0?
Greater than 0.
And did you calculate delta S?
Yeah.
And what did it turn out to be?
I got 44 joules per mole.
Joule per mole, degree Kelvin. Okay, so note this is positive, it should be greater than 0.
Oh, but I used 22 degrees Celsius.
That's okay.
Just close enough.
Note also that we're going from 1 mole of solid reactants to 2 moles of aqueous reactants. So aqueous products. So first we're going from 1 reactant to 2 products. So are we going from order to disorder or disorder to order based on the 1 to 2? Order to disorder. So note that if you're producing more products than the reactants you have, it's getting more disorder. Yes, that means the delta S is going to be greater than 0. Note the other thing is we're going from a solid state to a solution. So what's going to be more disordered, a solution or a solid? Yeah, a solution is going to be more disordered. So that also tells us that delta S should be greater than 0 too. Okay, so the analogy I like to use is if you take a beaker, which is 1 piece. Okay, so if you have 1 beaker and you accidentally, it slips out of your hand and drops on the floor, what happens to the beaker? It breaks. So now you have many pieces of a broken beaker. Note that you're going from 1 to many, so this has a lot more disorder than that beaker before it was broken. Okay, let's do it for the boiling water. So for boiling water, we'll do the same thing. So we want to calculate W. Let's see, work, Q and W and delta G, delta H. Delta S. So what's going to be Q for this reaction? Do we know right away? Greater than 0, because we know that this is endothermic. Which means that we can right away calculate or determine delta H. So delta H should be greater than 0. Does water boil spontaneously?
If you take the pressure, decrease pressure.
So is that spontaneous though?
Not
Okay, so based on under normal temperature and pressure conditions, what's delta G going to be?
greater than 0.
Yeah, so since this reaction is not spontaneous, this is going to be greater than 0. Does this reaction produce work?
Yes. Yes.
So is work can be greater than 0 or less than 0?
Less.
Yeah, so if a reaction produces work, that means work should be less than 0. Now, how do you know that work is less than 0?
Delta N greater than 0.
Yeah, because note that we have 0 moles of gas reactants going to 1 mole of gas products. So that means delta N is going to be 1 minus 0, which means that delta N is greater than 0, which means that delta V is going to be greater than 0. Note that we have an expansion occurring here, which means that work, which is equal to minus P times delta V, work is going to be less than 0. So this was the idea behind steam engines 150 years ago, or whenever the steam engines were invented and started to be used. Okay, so note that by producing steam, we can produce work. What about delta S? Is that going to be greater than 0 or less than 0? And how do you know it's greater than 0?
Liquid to gas.
Yeah. It's like Juan says, we have a liquid going to a gas. A gas is more disordered than a liquid, so we can predict that delta S should be greater than 0. And if you do the calculation using Hess's law, delta S should be positive. Okay, let's go on to part D. So which reaction is favored by enthalpy? So is this reaction favored by enthalpy? No, because delta H is greater than 0. And is boiling water favored by enthalpy? No. Is this reaction favored by entropy?
Yes.
Yep. And is that reaction favored by entropy? Yeah. Okay, so note that these two reactions are favored by entropy but not by enthalpy, which means that there's going to be, this is part F, there's going to be a temperature at which each reaction either occurs or does not occur. Okay, so we said that this reaction does not occur spontaneously, but there's going to be a temperature at which it does occur spontaneously. Okay, so we can calculate the temperature. Okay, so based on these three quantities, we can use this equation. Delta G is equal to delta H minus T delta S. So what we want to do is we need to calculate delta H for this reaction. We need to calculate delta S. And to figure out the temperature at which this reaction will occur spontaneously, what value for delta G should we use?
0.
Okay, 0. So we do this. 0 is equal to delta H minus T delta S. Then we solve for T. That tells us the temperature at which this reaction will occur spontaneously. And the same thing is true for the NaCl dissolution. So we can look up or calculate delta H and delta S, use the same equation, set delta G equals 0, solve for T. And that'll tell us the temperature at which this reaction does not occur spontaneously. Okay, so should we do that calculation just for practice, or just by talking about it, that's enough? Too much talking? You need to move on? Because really teachers talk way too much. I'm trying to make you guys do more of the work and you do the rest of the time. Because I've seen myself on those videos and it's terrible. It's awful to see myself on video. That's why I'd rather have you guys up here. You guys can be on video for the World Wide Web to see. Okay, so which one should we do? The one for water or the one for the NaCl dissolution? Water. Okay, so what's delta H for? Let's calculate delta H. So let me erase this part here. Okay, so if we look up the delta H in formation, so let's do that. Okay, so look at delta H and delta G in formation. So for H2O liquid, okay, so for H2O liquid, this is minus 285.8. And actually, we should look at delta S. For delta S, that's going to be 69.9. And for H2O gas, it's minus 241.8. And for H2O gas, 188.7. So based on this, we can calculate delta. Let's see, so delta H of the reaction is equal to minus 241.8 minus a minus 285.8. And then for delta S, of reaction. That's equal to 188.7 minus 69.9. So when we do these two calculations, we get 44 kilojoules per mole. And then for this one, it's 118.8. This would be joules per mole per degree. So now we can plug it into that equation I just erased. Okay, so note that delta H is in kilojoules per mole, delta S is in joules, so we want to convert from either kilojoules to joules or joules to kilojoules. Okay, so
I'll be point
this would be point
1188.
and we solve for T, so let's see, T is equal to 44 divided by point 1188, and that's equal to
370.
what was it here?
370.4.
370